Understanding scikit-learn's generic univariate select. Generic univariate select in scikit-learn sklearn is a powerful feature selection tool that provides a flexible framework for applying various univariate statistical tests to select relevant features. This method excels in situations where you want to identify features that individually exhibit a strong relationship with the target variable, without considering complex interactions between features. Let's break down the key concepts and functionalities of generic univariate select. 1. Univariate feature selection. The core principle of generic univariate select is to assess the relationship between each feature and the target variable independently. This means it doesn't consider how features might interact with each other to influence the target. This approach is particularly suitable for situations where you have a high-dimensional dataset with numerous features. Computational efficiency is a concern. You want a quick and simple way to identify potentially important features. 2. Statistical tests. Generic univariate select leverages various statistical tests to evaluate the relationship between each feature and the target variable. It supports several common test families. F-classif and regression. These tests are suitable for classification and regression tasks, respectively. They measure the variance explained by each feature relative to the total variance of the target variable. Chi2 used for categorical target variables. This test evaluates the dependency between the feature and the target, measuring how likely the observed distribution is if the feature and target are independent. Mutual info classif and mutual infogression. These tests measure the mutual information between the feature and the target. They are particularly useful for capturing nonlinear relationships and are more robust to non-normal distributions compared to F-tests. Select K-best. This is not a specific test but a strategy for selecting the K features with the highest scores based on the chosen statistical test. 3. Selection strategies. Once the statistical test is selected, generic univariate select offers different strategies for choosing the features to keep. Percentile select a fixed percentage of features with the highest scores. K-best select the top K features with the highest scores. Threshold select features with scores above a specified threshold. 4. Flexibility and customization. Generic univariate select provides a flexible framework to fine-tune the feature selection process. Scoffing parameter. You can specify any univariate statistical test function from scikit-learn's feature selection module. Mode parameter. Choose between percentile, K-best, or threshold selection strategies. Param parameter. Customize the selection strategy parameters like the percentage, number of features, or threshold value. 5. Example usage. Python. From sklearn, features election import generic univariate select. Select K-best. F-classif. From sklearn, datasets import load iris. Load the iris dataset. X, Y lotteries return XE true. Select top 2 features based on F-test. Select a generic univariate select F-classif. Modicbest. Param 2. X selected selector. Fit transform X, Y. Print for original feature shape X shape. Print F selected feature shape X selected shape. In this example, we first load the iris dataset and then define a generic univariate select object using the F-classif test K-best mode and keeping the top 2 features. After fitting the selector, we apply it to the original data X to obtain the selected features X selected. 6. Key considerations. Nonlinear relationships. Univariate feature selection methods might miss complex interactions between features. If you suspect nonlinear relationships, Consider using other methods like RFE recursive feature elimination or feature importance scores. From tree-based models, data preprocessing before using generic univariate select. Ensure your data is preprocessed appropriately, including scaling, normalization, or handling missing values. Feature interpretation. While generic univariate select helps identify relevant features, it doesn't provide insight into the nature of the relationship between selected features and a target variable. Further analysis might be required to understand the underlying relationship. 7. Advantages. Simplicity, easy to implement and understand. Efficiency, computationally fast, especially for high-dimensional datasets. Flexibility allows customization with different statistical tests and selection strategies. 8. Limitations. Limited interaction, ignores feature interactions. May miss important features, can overlook features that might be relevant in combination with others. Sensitive to data distribution, can be influenced by outliers or non-normal distributions. In conclusion, generic univariate select is a valuable tool for initial feature selection, especially when dealing with large datasets or needing a quick and efficient way to identify potentially important features. However, it's crucial to be aware of its limitations and consider using other methods for more comprehensive feature selection if required.